Okay, you can see my screen. Let me hide this.
Yes, sir. Yes, sir. We can see your screen.
Okay, so today should be the third day. Is it the third day or the fourth? I think this is the fourth day of our meeting, but it's just an extension of the other class, so I still
Thursday.
captioned the lesson two. Yeah. So today we'll be talking about data definition language, data manipulation language, and data control language. SQL statements are just divided into these three, although there are some cases where people have like some extensions up to four, like they call it transaction control languages, but we'll do a little bit of definition language and now focus fully on data manipulation. For data control, it's not like we won't be doing it, but for like our scheme of for our program, this our program, I don't think we'll be doing much about data control. So the objective of today's class is just to introduce data definition language, introduce data manipulation language, then data control language, a little on DDL, that's the data definition language. Then we'll now finally dive deep into data manipulation language. Then try to, if time permits, we'll also go over the main clauses in select statements. So what is a data definition language? Data definition language are those statements we use to create our schemas, our tables, our databases. So we use it to either create, drop, or alter. If we have a database and we don't like the structure, maybe we would like to include something like address. Initially, while we were designing it, we didn't include it. So we are going to use an alter statement. We've seen a create statement in action. We just use create statement to create our databases and create our tables. Then, in case we want to drop maybe a column or a database or still a table, this is where we use drop. So whenever you see us using a create, alter, or drop, what we are dealing with is data definition because that's where we define the schema, the structure of our database. We use these clauses define the structure of our language. So for data manipulation, this is where we now start doing things like insert, delete. Generally, people tag them as CRUD operation, which is create, read, update, and delete. So that is the data definition language. And that's where we'll be focusing more of our attention throughout the rest of this program. So this is the set of SQL statement that focuses on querying and modifying data. So basically what I said, you can read up on that. Then for data control language, we use it to grant people permissions, the level of permission someone should have. Or maybe we have a database and we ask someone to design an app that will do whatever, but the app is going to interact with our database. We give that person some level of permission, not almost everything. Maybe that person might not be able to create, or sometimes if you make a create request, someone needs to commit that create, which is more like you initiate it, but someone has to inspect it before making it impact. So this is what we do with control language, and that's just it. So basically, we won't be doing much about this. We won't be doing much here. We'll be focusing more on data manipulation languages. So to create a database, we simply issue a command, create database, then we give the database name, which is this. So let's try doing that. I'll try doing that. I think my SQL Server control sheet. All right. So to create a database, I was trying to, let me just say, um, to create a database, this is still active. Okay, I'm going to drop this database. Let me just move to, I was trying to,
Ẹ kó jẹ́ kí gbogbo kinní yẹn empty ní báyìí kó ṣẹ̀ wá bẹ̀rẹ̀.
someone said that this thing is on, mic is on, drop database, uh, lesson two. So to create a database, we simply issue the command like we saw, and a database will be created. This is not gone. Let me delete it from. If it's not going. So for SQL Server, for other databases, you must always include this semicolon. But for SQL Server, it's allowed for you not to have that semicolon and still get your desired results. But I want us to get in the habit of using that, because when you move to another database, you might struggle with getting used to it. So we can just say create database. Again, you can use we can just say illustration. Do I already have illustration? You can use small letters or capital letters. Then as we go, I'll be also mentioning the other day I told you this is for you to create a comment. A comment is just a part of your code that is not executed. Like it's more like it's opaque to the compiler or whatever runs your code. I don't know if you can still hear me. So I'm
It is
going.
more like explaining what you're doing to the code, right?
Yeah,
If you
yeah,
put
yeah.
those
So,
two, okay, okay.
yeah.
So it
So
does not
it's
run. If you run the function, you
yeah,
dash in front.
yeah. So that's exactly what
Okay.
it does. Is yeah, it's not visible to your compiler or whatever to the interpreter that interprets our code. It's just to inform whoever is going to read your code what you're trying to do here. So running this will create a database for us. You see, I even selected that dash create database, but there's also another way we can make comment. If we refresh now, we are going to see that we have that database. Let me disconnect. It's supposed to just appear without stressing me this way, but I don't know why it's showing. So once you do that, we already have illustration, but illustration has no table in it. So the next is for us to use that database. In order to use that database, like we already know, you can either come to this drop-down list, select the name of that database, or you just use a query that says use the name of the database. So use illustration, comma. So on that, this thing, when I was talking about comments, you can also use this kind of comments, which is / asterisk or star, however you want to call it, / asterisk. Why this not showing? Then you type whatever we are about to switch to the new database illustration. So once you're done, you still do asterisk, then your /. The difference between this one I used and the previous one is this can handle multi-lines. This only works on a single line. But if you want to have maybe more than 2 or 3 lines of comments, you use this. Otherwise, you can also prefix each of them with this --. It works the same way. So doing this takes us to the newly created database. Let's execute this. Remember, executing the whole of this will give us an error. Why? Because once you run it, the interpreter is going to look at our codes line after line. Already this is created, so if we try running this, it's going to tell us that it's going to give us an error that a database illustration already exists. So on that note, we only execute this. Executing this will move us to the database. So in order for us to create our table, we'll simply use that create table again, which is still, we are still in that data definition language. We still, yes, use create table. We can use users. I think the illustration I have on our slide is users. So once you do users, the next is for you to start listing your columns. All the columns you want to appear in your database, you start listing them one after the other. But in each of them, after listing the name of the table, the name of the column, next you list the data type and some other constraint. Like in this case, we can just say user ID. So our user ID normal, we know we used to select them as integers, right? So we are going to say integer, not null, then primary key. So all we are doing is just listing all of those we used to do there. The order doesn't matter. You can bring this not null outside after primary key. And I think that's how most people do that. So say primary key, then not null. So what this not null does, what this not null does is it unchecks that our blue button that we used to check, allow null. So once we say not null, it means we don't want to allow null, right? So next
Yes, sir.
next we have let me just follow this thing and explain to us what we've done. So create table. To create a table, the syntax is just simple. Paste table, table name, then column names like column 1, data type, other constraint list, column 2, data type, another constraint list, up to the n number of columns. That's the number of columns you want to have. But the basic thing is for this to qualify as a table, it must have a primary key. So even if you don't want to have so many columns there, you must at least equip it with that one column that will be our primary key. So the illustration is what we are trying to do. We have a user ID, which is an integer. Okay, I forgot to make it an identity column. We know how our identity columns work. If you have it as an identity column, what does it do? I know we've done that. What does it do for us? If we have ID 1, 1, I think what does it do? Sorry.
Yeah, it tells us the progression.
Yeah. So
Yeah,
it tells
if
us
we start with 1, is it progressing in 1, 1, 1 or in 2, 2, 2, depending on what we started with.
Yeah. So starting with 1 means once we enter our first destination, start with 1, then progress at 1. And another advantage is with this now, you don't need to bother about inserting. Maybe if you create a user, you're not going to be saying user 1, user 2, user 3. So you can actually leave it, and the server itself auto fills them for you. So not now. The other stuff would like to have should be, I think, first name. I think first name. We can have first name and first name then address. So our first name, we can have first name. Just look at it as what we've been doing from our command line. First name. I mean from our this thing. So what's supposed to be our data type for our first name?
Envasha.
Okay, Envasha. But I would like us to define it as SHA because I want to modify it later. So we can just say SHA 50. I want to use
Does
it
it
to
mean that does it mean that if you use Envasha, we will not be able to like modify it or edit it or something like that?
No, you can do whatever you want with them, but I just want us to leave it as Envasha. So that's what's happening. Yeah.
Okay.
I want us to leave it like this because later when we'll be treating how to alter table, I told you for data manipulation, data definition. I don't know why this is giving this mark on my system. So for data definition, we can create alter or drop. So the language for dropping or deleting a table for deleting a table is drop, is not delete. So let's leave it as this. So it's going to be our first name. We don't want it to be null, right? So we simply uncheck. Yeah, we simply uncheck the other stuff. Do we want to give it any other constraint? So we can say address. We want to have address. And our address is going to be what? How do we store addresses? So it's going to be Envasha. We can be very generous and give them up to 100. Then do we want it to be mandatory? We can leave it as optional. Sorry, I'm coming. My system is misbehaving.
No, you move the airport, you hear someone.
Huh?
You move the airport, you hear someone.
Huh? No, it's far. I want to use the airport.
So remember, why we are having this error message, why we are having, whenever you see this squiggly red line, it means you are making a mistake. So you can very quickly go back and trace your errors. Our error is for each of the column name we give, we are supposed to put a comma until we get to the last one. From the last one, it's no longer, it can be, you can leave it. So now we want to have address and close everything we are doing about this table. So with this, we are fine. But I just want to also mention on naming conventions. You can't, one of the naming conventions, I would have, maybe I'll include it on the slide before I push it out, is that you can have Arabic, like you can just have characters, but don't start with 0. If you start with anything numeric, you're going to have an error. You see, I started with 1 illustration. It's giving me an error. The same thing goes with our table names. You can't start with 1. It will still give you an error. Just anything number, you can't start with 34. Is an error. So these are naming conventions. Then same thing with the column names. So our address. Why is this? So don't start with numbers. Always start with this thing. But I think you can go with underscore. Underscore is fine. There's still another character that is allowed, but I don't see the reason why you should be doing this. I think just going with a very descriptive name does the job for us. So always start with what's it called? Our alphabet, like characters that are not numeric, or special signs, like you can't come and say plus. I mean, let me do it here. You can't start with plus. You see, it gives us an error. So always start with letters within the range of A to Z. You can include underscore. Then the other stuff is, if I want to define my tables, I can't say users and give space. I can't say user, maybe user table. Something like this is wrong. You understand? So you're not going to space them around. If you must do that, you need to tie them with double quotes. The same thing goes with our user, like here. You see, we have user ID. The longer you interact with databases, the more you get familiar with how people define their stuffs. But if you, I mean, you can't say something like first name. This gives us an error. If you must give first name, if there's any reason why you should do that, always tie them with double quotes, not single quotes.
What did I tell you?
So this is now valid. And this is also valid. If I want to start with 1, I have not tested it before. I think it's also valid too. Once you tie them with double quotes, that error message goes. So this is more like a way of circumventing the rules. For SQL Server, there's yet another sign, another character you can use. If you use this parentheses, the block parentheses, you can also give space, but I don't encourage doing that because it's not going to work on other databases. So let's just stick to double quotes if you must use space. So with double quotes, we are able to circumvent some of those rules, like the one that said you can't start with digits. With double quotes, you're able to circumvent it. The one that says you can't have space, with double quotes, you can circumvent it. And we can also have a special character. Maybe we want to have ampersand, I don't know. Maybe we want to start with asterisk or hash, first name. So with double quotes, it's not giving us any error. But outside the double quotes, we are going to have an error. So these are just, before we forget, on naming conventions. As we still interact the more, we will still touch on more of them as we progress. So in this case, we just want to have it as first name. But there are cases where you'll be renaming your column names if you want to export. If you now want to, maybe if you want others to see it, you're going to do user identity or whatever. So with this, I think we are good to go, creating our first database. But always remember to put this. So we execute this and have
Excuse
a
me,
database
sir. I
created.
have a little question, sir.
Okay.
What if we want to make the address not null? Make it null. How do we do it? Do we just type
No,
null?
you just leave it.
You just leave it like
It's
that. Therefore, means it is null already.
yeah, it's not null, but it is nullable. Being nullable means it allows you to not specify a value for it.
Okay, I get the point now. Thank you,
Yeah.
sir.
So saying not null means you want to. That's the default. By default, it is always a nullable. Like it can allow you to have null value by default. But if you don't want it to now allow you to allow null, you have to specify that not null. If you watch when we are creating it graphically, that's not allow null is always checked. So that's the default. So
Okay,
to
sir.
overwrite it, you have to specify not null. So with this, I just ran this and we already have our table created. If we now come into tables and expand table, let me refresh. We didn't have any stuff in our table. So if we now refresh, come back to our illustration on tables, we should have what? We now have this user table. And if we try to expand more, click on this plus and see the columns we have therein. So with this, we should see that we have user ID, which is just a reflection of what we have here. We have user ID, first name, address, and it also tells us the data type and whether it's nullable or not. Like this address you were asking, you see, address allows null, but first name doesn't allow that, and the user ID doesn't also allow that. So it tells you this is the primary key. This one can accommodate. It takes a SHA-50, not null, address. So do we have any question around this?
No, I think I'm good here so far.
Yeah. For
We are
others,
good to go. You can
so
continue.
everyone is fine.
Yeah.
How about the ladies?
If you see this Sunday,
No.
you missed a lot to this
The
Sunday.
ladies said we used to leave them. So
Wow,
someone is
God,
talking in the background.
Well, going to
So what next can we do? We can alter this table and add more. Of course, this is not making sense, just having the inside the first name address. So we can alter the table and add more columns, right? I don't know what's come over my system. So we can alter the table and add more. Let me this here and possibly this here. That is not good. So we can alter the table and add more columns to it. I allowed it so that we see that in action too. So to just do that, all we need to do is what? Declare alter table. You give the table name, alter table. You give the table name. In our case, it's users. Then you start doing whatever you want to do. So this is the syntax. This is the syntax. Just alter table, specify the table's name. Then in this case, we don't have any open or close brackets. We simply go down and start specifying. You can actually do them on the same line, but you won't like it because it's going to go way to the right, like such that you won't see them. So just move to the next distance. You can add a column, then give the same column constraints. If you want to drop a column, just drop column, the name of the column, alter column. Then for this alter column is when you want to change the data type. Like in the case of that, there was a column we defined that I said I intend to overwrite. So how do we do that? We are going to add last name, email created as, then drop some of them. I don't want to use that address. So let's do that. Let me get this smaller. So let's do that. Next, we do what? We alter the same table we've created. We already have the table there. We say add last name. Then what's supposed to be the distance of our last name? The data type. Yeah. So last name is supposed to be Envasha. Let's say 50. Let's allow 50. What next? We move to the next. Okay, so for other databases, this is supposed to work. We are supposed to give a list of other alterations we want to make. But for some reasons, I tried it this afternoon with SQL Server. It's only allowed one at a time. So I tried to do more, and it was giving me error. So I tried to search, I couldn't see. So it's like we'll be adding them one after the other. I want to add a column. Last name is going to be Envashadis. So do we want it to be null?
No.
We don't want it to be null. So with this, we can just do our closing. This is like our full stop. Then run this. It's going to add. So once it says command completed successfully, if it gives you some red this thing with some error messages or exceptions, you know it was not successful. You try it, trace back. So if we refresh now and still check our table, if we still check our table, which was user, we'll see that okay, it was on this. We'll see that this thing has already been added with the same constraints we specified.
Sorry, is
No,
comma
not
not necessary and after the author table?
yeah. There's no comma needed.
Okay.
Had it been one to list, look at this for creates. We created and we gave a list of columns. So in the case of we listing giving a list of columns, we need that comma. You can even do this. This is valid. But just for us to be able to see where, we'd like to move it to the next line. So we'll be seeing what we are doing. So in this case, we already have, it has added last name, giving it a data type, and also specified that this is not null. So giving a null value here, we'll still return an error message. We are also going to add email address. So we already have the email, this thing. We simply say email, welcome. So our email is supposed to be of which data type? What should be the data type? So we still go with Envash. It can be using a small letter, it still goes. But me, I like to, and that's the standard. You should just follow that standard. But so always allow it to be. We can make our email address to be up to 100 characters, right? Or even more. Some people have long in there. So doing this, we still add that column to our table. It has added. Maybe we'll check later. So once we also add this other one that says created at, we can say add created at. So created at is just going to tell us when the user was created. So if a user is created today, it will tell us that this user joined our platform on so day. So we are going to use what's supposed to be the data type for that. I want to store
Dates.
So it's going to be a date time. We have a date time in this case. But because we want it to always give us the current time, like exactly when the user was created, we want to use another constraint called default. So what default does is it gives it a default value. And what we want to use for this is just we will still touch more on this when we start when we start doing a time series analysis. We want it to get the current date. That's what this is called a function. We are going to treat functions when the time comes. But just see this as a function. And to use a function or to declare a function, functions are always equipped with open and close brackets. Whatever we find inside that open and close brackets is what we call the arguments. So if it doesn't click now, don't worry, we'll get to that. We are going to do treat functions exhaustively. Hello, someone was trying to say something. So I'm going to continue. So you see, like I told you, for some reasons, this is not allowing.
What I wanted to say,
Okay.
can you hear me?
Yeah, I'm with
Yes,
you.
yes.
Hello?
Maybe it's network.
Yeah, your line is breaking.
Sorry, before we continue, instead of us writing alter table, can't we go to the syntax where we create the table and continue after when we have run the execute the syntax instead of
Yeah, we would have done that, but my interest is to introduce data definition language, which we have auth as part of it.
okay.
So like the first this thing introduced us to how to create a table, which is using this create. I told you we have create, author, and
Pattern and
which other
drop.
one? Yeah, and drop. So what I'm trying to illustrate now is just the how our author works.
Okay.
We could have just done it once, create table, give it whatever we want. So in this case, if we run this query again, just select this part, always select the one you want to run. If we run it again, it's going to add this created ads and it's giving it a default value, which means we don't necessarily need to always type it in each time we are inserting into our table. So we can run this and have another table like that. Maybe for now, we can just do check to know how many is already added. So for this, I'm going to go to our illustration table. Okay, we are still there. And just click our distance to see if we have more added already. So on tables, we are going to come to our users. Then just click on columns to know how many columns. You see, email is already there. Then created as is also there. But created as is null. And maybe we don't want it to be null because whenever we forget to add, it's going to just add null to that. So we are going to also alter that. But before we alter that, I wanted to drop that to drop the distance. So we can just say drop table, drop column. So if you want to drop a column, you don't need to specify all of you don't need to specify all of the data types and all of that. So we can just say drop column address. So I don't want the address to appear in our distance. So like I told you, this doesn't allow to. If we want to run this, we can just comment this out by doing dash dash. So doing dash dash makes this valid now because this is opaque to our interpreter. So running this again, I'm just showing you how else you can use commenting. If you write a code that you're not sure of or you're trying to debug your code, you could be looking for which is giving you that error. So some of the way we do that is to just do, you can just comment out a part of the code. We call it printf debugging. So with this now, I can still run this. So what I'm just running is alter table users, drop column, this. I'm not running this one that appears on green. So we are going to do that. And that goes. So it goes. And I want to alter first name. I think we have to alter this created as and make it something else. It's fine as date time. It's not, but I don't like it to be nullable. So we can just do that. We can say alter table. In this case, we are going to use alter again. So if you watch the keyword, what we are simply using is create alter, add. We are not going to do rename. Renaming will require us by SQL Server standard to call what is called the stored procedure, which is more like it's a bit advanced. We will not treat it in this thing. But it's something you can also, as you get comfortable with SQL Server. So we are going to alter that column created as. No, it was created as.
Must it be the
Then
same
we,
character?
yeah, I simply want to just say not more. I do believe this is going to alter column. Alter column. Not no. This should go. It's not giving me that. It's not giving me that. But it should go. So alter column name then. All right, let me just drop it and recreate. Sorry. Let me just remove that one. I can just say drop column. Because I want it to autofill drop column. Created created as. So with this, if we run this, it's going to remove that column so that we'll be able to.
Now this
Yes.
column we want to drop. If you use
Yeah.
capital letter instead of the when we write the character, will it work for it?
Where for this?
Yes.
No, it's not going to work. It's just going to work the way we've defined it.
Okay.
Objects. I'm coming. It's saying this failed because one or more. So just always follow how you've defined it. Which this thing is accessing it now. All right, we can leave it for the ball. It's supposed to drop column this. It's saying something is accessing it. Nothing is accessing it. So let's continue. I'll get back to that. Which other column did we want to add? Wanted to alter first name. Okay, so I intentionally created first name like I said. We can alter first name. You can also use this alter first name. Alter first name. Then you now give the data type you want it to be. It was initially what was it? So we want to now make it mVasha 50, which is the way we want to have it, right? So we can comment
Yes.
out this or completely remove them. Alter column. So first name. So this is now correct. Allowing spaces is just for the beauty of your code. You can allow spaces, but it's not recommended. So doing this, we change our first name. If we do this now, you see, our first name was formerly SHA50. So if we refresh now and try to fetch our first name, you see it must have turned to mVasha. Yes, okay, this should be. So come to columns. This is now mVasha because we have altered it. So you can use this, but don't do this. This is not good. Don't use the small letters. It's painful typing in capital in block letter, but just do it. So let me try to. Now we have this table, but I had wanted to have that as what it's supposed to be. So I'm going to drop that column. Drop column. If you're just driving insight or trying to understand your database, see how things are, it's allowed for you to write those small, not to follow conventions. But if you are going to write a query, maybe you'll be saving to use later or some other person will be using it. It's best you stick to that conventions because it will even help you when you're trying to understand what you did later. Because those keywords will always stand out for you. So I'm going to drop this, what's it called? It was which this thing we want to drop. Which column did we want to drop? Sorry. Okay, created as. Created as. So running this should drop that so we create it.
You don't put your ads.
You say? Okay.
Your art is missing.
Okay. Thank you so much. So let me see if this goes. So if we do this.
The T there is not capital, it's small letter.
Okay. Thank you. Let's try. If it doesn't, we'll leave it. The objects this is created as is dependent on column. Created as because object access this. So I'll fix this, but I had wanted to just have a table that will have so that it will autofill. So now we've created a table. Creating a table is just more like drawing your lines on a paper where you want to have serial number, first name, so name, this person paid this amount and the rest of them. We have our table called the user. And if we want to see the nature of that table, maybe we can look into our schema, the object explorer to see what columns we have there, or we can just run a quick select statement You can do this for short, but since we are beginning to write our own select statement, you can do this whenever we do select asterisk. What that means is select everything, select every column. So we can do select asterisk or select star from our users. So doing this, we just select everything from our table, but since nothing is there, it will just give us the headings. So we already have a table that stands like user ID, first name, last name, email, then created as. So let's go ahead and fill in some data. If we want to drop this database, let me just demonstrate the drop too. Since we are doing a data definition, we can simply say drop database. Drop database will drop the whole database, but we can just say drop table is the same thing. Drop data, drop table users. So if I run this code, it will delete that our user table. So it will just delete this stuff, and maybe we'll start afresh and do it faster. So it's gone. Refreshing this, our table is gone. So for data definition language, we have what? If we do this. For data definition language, how many keywords do we basically have? So we don't have any table again. How many keywords do we have? Sorry.
3.
We have 3 standard keywords, and those are
Create,
sorry.
alter, and drop.
Yeah, I would like you to be participating in this class. If you ask questions or answer questions, it gets you so interested in what we are doing. So we have create, alter, and drop. So we've successfully dropped our database. We don't have anything left there. So in order to recreate it so that we'll move on, we can
Sorry,
simply,
before we continue, for that
yeah.
drop column, can't we select only drop column and we should not execute it together with the alter table?
Yeah, we did that. We
No,
dropped
you
address.
selected it too.
Yeah, there was a time we dropped address. There was a time we dropped a column called address.
Yeah.
It was gone. So, but in this case, you can either drop a column. Maybe you want to remove a column. You don't want a column. You want to reduce, maybe people are not supplying address or whatever, or you don't want the address to be there again, or you want to move it to another database and create a relationship. You can just drop it. You can drop a table. You can also drop a database. Dropping a database will just delete our database completely.
Completely from the,
Yeah.
So there's nothing like maybe recycle bin or.
No, we don't. It's one-way stuff.
Yes.
So, but for you to drop a database, you need to move out of that database. Like this one is active now. If I write a query that drops this database, it's going to tell me that it's the active database. Let's say drop database. It was illustration. If we do this, it's going to generate an error. We'll just run this alone. It's going to give us an error. So it's telling us that the database is currently in use. So in order to not use it, we just move away from it. This is handy. We can move to master and run this query again. So running this query again, we let it go. We don't have that database again. If we refresh now, let's, why is this taking time? So if we refresh now or disconnect, I don't use to. If we disconnect and reconnect, that database is gone. Remember, our server can host so many databases, like all these are different databases. We can't see that one again. Let me try dropping this to that lesson. Because so we can drop lesson 2 where it's not active. It should go to. So that's basically how we do data definition. A data definition language is basically creates, alter, and drop, which is delete. Okay, I don't
Sir,
know.
sorry, please, I have a question.
Another name for delete.
Okay. Yeah, it's not another name
Hello,
for
sir.
delete. The name is just drop. You can forget delete because delete will get you into trouble. Yeah. think of it as drop. Yeah, someone
But the drop
wants
now
to
is
ask
as
a
if
question.
Yes, I want to ask a question.
Yeah,
When
the
you
drop is
you're
alter your
deleting it.
okay. Sorry, let the other person finish. You're saying that the drop is more like delete, right?
Yeah,
Hello? Yeah, so that's what it is, and that's how
yeah, I can
if
hear you.
if you're talking to database, you should use drop. Don't just forget delete. Think of drop. Drop is the name. Yeah. Yeah. So someone was trying to ask.
yes. If you alter your table and want to add another column to the existing ones, can you add two at a time? Because I noticed when you want to add to your table, add a column to your table, you clean the first one, then add another one. Can't you just add two at a time when you alter the table?
Yeah, for some SQL, for some servers, like I think MySQL does that. It allows you do that, like do many alter operations on the go. But for some reason, I don't know. I just realized today when I was trying to prepare for this class, I tried to alter minutes ago. It was giving me an error message, so I couldn't really figure why. So I think
Okay.
it doesn't allow that. For SQL Server, like I told you, SQL is just a language, but we have dialects. What we are speaking currently, though I'm trying my best to speak the standard SQL, what we are speaking that currently is T-SQL, that's Transact SQL, which is Microsoft this thing. So I don't know if we have more questions so that we'll carry on with in that. All right, so basically what we did is just create our tables, the structure of our tables, but we've not entered anything in it. I would like us to, okay, we dropped the other table. So, and we dropped this. So let's do this again. We can reuse our code. The database is gone. We can just come and run this. It will give us a database. So we already have a database. If we refresh, we should see it. So illustration is here now. Then maybe we can still use this to switch to that illustration. But this will give me an error. If you write a multi-line comment and you want to run, don't select it halfway. Halfway we just read from here. It's not seeing this forward slash. So running this is equal to an error, except if we run it completely, or we can just select what's important to us. So now we'll switch to that database. Now to create this table, I don't know, maybe we can just go ahead and create everything at once. So to create everything at once, I don't want this. Do we go ahead or we still go over? I don't want this, so I can just go last name. My last name is going to be Mvasha. And if I'm going to be doing this, that means I should also correct this to Mvasha, right? Mvasha, not no. Our last name shouldn't also be no. Maybe we could add, let's just add other names. Other name. Other name should also be Mvasha. I'll call it 50. But we allow it to be nullable, right? Then which other thing did we add? We added the other names. Then email, we can add email, right? So before you add anyone, remember to put comma. It doesn't matter. It doesn't matter if you put the comma here, but some people like doing this. But me, I don't see it. I don't like it. So we can just say email here. It's still not wrong. Our email should be an Mvasha. Mvasha. Why am I doing this? Mvasha. We said we can leave it at maybe 150 to just give her more rooms. Then what other column did we add? So you see, this is not giving me an error. Doing my comma here doesn't give an error. And having more than one on the same line doesn't still give an error, but I don't prefer to do that, to do things that way. So you can be doing what I'm doing, or if you So we have email. Which other one did we add? From where we were dropping, we added the created ads. So this other time I'll try and get it right. I don't know why it was not dropping. Created ads. We are going to have created ads as a date time, right? The date time. Then we default it. Yeah. We make it have a default value of gate date. So this is a function. It will just fetch the current date, but we also don't want it to be null. We can just say not null, so that when we don't specify, we can actually override the current date, but we can also make it not null. So we say not null. The other doesn't matter, but I like it when we have them like this. So all the constraints you're listing, you don't need to give spaces around them. These are just like some integrities. You want your data to have some integrity. It must be, if anyone tries to put anything that is not date, it should raise an exception. You can't leave it as no, it should raise an exception. And if you don't specify any value, it should get the current dates for you. I don't know if we had created as email, last name, and that was just it. So we can just go ahead and create this and still have the same result we had earlier. So now let's go into our tables and check what we have. We have this, and if we expand and see all the columns, we should still have the same thing we had after authoring, but this is no longer null, right? So how do we load data into, let me just give some comments because I'll share some of these codes with you. And the other stuff is
Coach, please, can you close this coding page and let's go back to it again? Let's assume maybe you are busy now when you were creating your code, then you close it, you want to come back to it.
What is?
if you want to do that, you have to save it. You can just do Control S. It will ask you for where you want to save it. So you look for a convenient place you can remember. Save it. Close our listen. So maybe we can just say, let me just keep it on the desktop. Then you give it a name. We can just say illustration. Just leave it as SQL. Don't save it as the other formats you can save it as text, but I don't think there's any reason why I want to do that. So always leave it as SQL and save. So if we do this, I think we selected the desktop, right? If we save this, it's saved. We can close this, come back next tomorrow. As long as we have access to that file, it will return us to save changes. Yes. That was what we did now. So we can just say illustration.
Oh, that's a different file, Mike.
You are saving again.
Okay. But okay, thank God. Oh yeah. So we have one. Maybe this to me like the most recent. I'll delete them.
No, that's a different file, Mike. That's another test file.
Okay. Sorry. So this should be correct.
Yes.
Okay. So let's just allow it to load. So you can write your code and share it with some other person, which we will soon do. I think from our next class, we'll load a database from an already created edition. So let it just load. We'll reconnect. My system is trying to be slow today. I don't know. So with this, we are back to exactly where we were.
Okay, thank you.
Yeah.
Thank you.
Yeah. So I will also share this once we are done. I wish I had no, not this. This is not it. So and if this is already opened, it's faster. I think this should be the correct one. So clicking it simply loads your. So this is the one we are working on, right?
Yes.
Yeah. So it loads it back, and you're back to where you used to be. So I was trying to write a comment. So creates a table users with some columns. So once you're done, always remember to do this. If you do it, it reactivates it, because if you allow it, that means the rest of your code is still under comment until you close your comments. So to close our comments, we'll simply do this and it's gone. I don't know if we ran the query the other time while we were doing that. I think we already ran it. Sure, we don't run them now. We don't run them. We
Yeah,
have some.
yes.
Yeah. So this is just a comment to remind us what we are doing, maybe as you go through that. So the next thing is to add values into them. So we have some defaults. If you have places that are default, like whenever you have an identity key, there is also an implicit default. So it's just kind of telling it default to 1 for the first entry, then progress with whenever we add 1. So if we want to insert into this, we are now moving away from the data manipulation. Let me just write, we can just say, sorry, data manipulation language. I don't even know the one that is correct. So we just do this and now start. The first one is to insert. Let's just insert our this thing, some value into our table. So if we are trying to insert some values, we know user ID is already given, right? User ID will generate by itself. It will auto fill, right? So all we need to worry about is first name, last name, other name, email. We can also specify value for this created app, but if we don't do that, it's going to also autofill. So we can just say insert into the language for the first language. Let's just say insert. I want to also, this one talks about insert. Is an insert statement. And this is how it goes. Insert statement, you just say insert into, you give the name of the table. So we can just say users. Then you give some column names. So some of the column names, we know user ID is going to autofill. So we are going to start with what? First name, comma, last name, comma. Do we want to add other names? Maybe we can just leave other names so we'll see that now in action. We can say email, and after this, we just simply told it that this is where. Okay, someone wanted to say something. Someone wanted to say something. So for the values, we are
it's full vibration.
We can say Michael, then last name. My last name is Oko. Then my email, we can just say. So now, if you want to write a string, look at, we define this. We said this should be a string, or it should be a string of characters. It should just be a variable varchar. If you want to fill it, you now, when you want to refer to a string, you use single quotes, not double quotes. If you use double quotes, you're either referring to a table name, a column name, or something else. So always stick to single quotes. It's a place where people always get errors. So we are going to say, Michael. Just Michael at gmail.com. So with this, remember what we did. I told you this will fill by itself, right? This is required, so we must specify this. This is also required. This is not level, like this can be null. So we've skipped it. Then email. Email can also be, email is not that required. It's not required. We can give it. We can also decide not to give it. But created ads can generate a value for itself. So in this case, we are going to allow it to generate its value. And do what? We close with this. Like I told you, not doing this is not a sin in SQL Server, but you want to get in the habit of doing that. So before we go, let me just select our table to show you nothing is there. Select asterisk from users. Don't write like me always, because I'm not writing serially, sequentially from users is users, not user. So you see, that hints me that I have an error. If I select asterisk from users, not there. We are in the wrong database. So we have to move to illustration and do that. So if we run this, it's supposed to give us it just gave us the headings, but nothing is there. But once we run this insert, if all things work well, we should have a row, which is just a record. So a record is already inserted because it says that one row affected completion, this. So we try to do the same thing we did before. We now have my names there. In this place that we allowed no, we are seeing no, telling us that we did not specify any value for that. I would have also loved us to put unique. When you say unique, unique means you don't want to have any other value that looks like that in that column on this database. So for our email mostly should be unique, because if you're trying to sign up to a platform or you're trying to use an email that is already subscribed to a platform, we always tell you that the email is already taken. Username is always also unique. So to specify unique constraints, just the way we said not no, ID, you can simply come and also give space, just say unique. But we didn't do that. So that means someone can also insert another value with my email address. And if you look at the user ID, see it started with 1. It gave us that value 1. We didn't insert this value 1. We didn't also insert this value 2024, 9, 30th, 20th, whatever. What is doing this is this function. The fact that we said default to this. So let's try doing another. You can also do more than just a row. You can insert more than one row. Like this, someone should give me a name. So let's have someone's first name.
Samson.
Okay, so we can have Samson. And Samson's last name would be
Tunde. Tunde.
Okay. Yeah, so he's Tunde. Like, because we did not specify unique, I can also use this my email address for Samson Tunde. It's going to work, but we shouldn't be doing that. You can give us, let me just say samsontunde@gmail.com.
Okay.
Samson Tunde. Okay, whatever it is, tunde@gmail.com. So we are going to pretend as if, so in this case, maybe we want to overwrite that default, want to give it a value. We can say this
Can I ask a
Samson.
question?
Okay.
Yeah, in this in this email, is there no code to add the two names, like the Samson Tunde, together to create the email instead of typing it?
There's you know, we can't guess your email from your name. People use different names, like I don't know, you understand? Like people, you can't always say that.
Like sometimes, some firms they have a unique email for their staffs.
Yeah.
It might be your first name dot your last name.
Yeah.
So is there no code to connect the two names, the last name and the first name?
There's
Maybe
a code
Samson dot Tunde.
There's a code to do that.
Okay.
But let's get into when we start selecting, you see that in action. There's a code to do exactly that. When we start doing our text analysis,
okay.
Yeah, we'll do stuff like that. We can just select whatever. Yeah, there's a code to do that, but let's not rush. I don't want us to jump things. I'm very happy that today everyone is kind of flowing, like you guys are following what we are doing. So with this now, I wanted to override. So if I want to manually include this created as, I have to also specify it in the list of columns I want to insert. So I'm going to say created as, and this is the kind of giving us intelligence, which is it tries to suggest what we are thinking. So once you do this, you have to now say he was created at 21st. Oh, that's not 21st. So this is the convention 2020. So we are still going to use a string for this. When we get to we'll get to time series and which is when we will deal with our dates. So 2024, that's 0, let's just say 08 dash dash 12. So this is when this person was created. Because we did not specify all these other the minutes, seconds, and the rest of them, it will just add 00 to it. So let's try this. If this works, okay. We want to have more than, not just this. So because the first time we demonstrated how to insert just one value, just one record. So this other time we want to have more than one record. So we can do this. Why I'm just doing this is just to make the whole thing look good. So whose other name again are we going to use? Someone should also give us a name. Someone should also give us a name, sorry.
Okoronkwo Grace.
Okoronkwo. Grace. Okoronkwo is the, okay, so let us say Grace Okoronkwo. Grace. Then Okoronkwo. So remember that's a single quotes. We can just say Grace, I'm forgetting it. Grace Okoronkwo at gmail.com. So Grace Okoronkwo was created at say 2024 dash 04 dash, maybe you can say 23rd, and close this.
Sorry.
So with this now,
I want to, sorry. Hello, sir. If I want
okay,
to add the number to my, if I want to add the number to my email, will it affect the data type?
No, it doesn't affect it as long as you put them in double quotes. So you can put a number before, between, or after. But in a very standard edition, if we write a standard whatever that is validating email, some of those emails might be wrong. Like in this case, there's no validation to show that if you don't have Gmail, email, or whatever, you shouldn't go. Someone can easily specify something that like this as an email. So we didn't write validation for that, but maybe we can just leave it now for the sake of learning. But as you progress, whoever is designing the database will now decide what is a valid email for him. But let's just do this for now. So with this, we are able to insert two tables, two rows on the go. Okay.
For the date,
yeah,
the date separator, can we use the /? Or is
yeah,
there
you
that is
can.
allowed?
You can use a we can try it. I am not so sure exactly the format, but there are some format like if you start with the way we write this, which is 1208, this is going to give us an error because I think this is defaulting to American standard of their date standard. We can do some settings that will set this to be collecting dates in another format. But most times, if you try this, don't worry, when we start doing proper selects, I'll teach you, we'll discuss how to handle that.
Or does it
There are
take
some,
the date from our PC, meaning our laptop?
yeah, what happens for this now? You see, I told you before, like the first one we did, we allowed this created ad because of the way we defined our created ad. If we don't specify any value, get it. So this gets it by itself. But on this other case, we'll specify it and we want to write it ourselves. So it's not taking anything, it's the value I'm giving.
Okay.
So it's going
So
to
if
take the
we
value
have used the default, specify the date, we don't need to write it.
I didn't get that. I didn't get your question, sorry. So with this now, we can add more than one column. So selecting this and running should give us that. So now that we've run this, if we run this our select statement again, which is just like revealing what we have in our table, it will now give us, we already have this latest this thing inserted. But we are having null for this because we allowed it to be nullable. So what if we want to now not allow this to be null? We simply include it somewhere here. And including it means we should also attach it when we are inserting. So maybe we can insert more names. So which name are we using? Maybe in this case now, let's try doing that, doing others, right? Other name. And remember to include your this. So if you watch this, someone should give us a name. But if you watch this, you see it's using the date we provided, and all this extra timestamp or whatever is given as 00 because we did not give the minutes and seconds to. We didn't give it up to that level of precision. So it's going to give us what we gave. So let's have another name. I don't know if it's clear to us how to insert just a single row and how to insert more than a single row. So let's just insert maybe 2 or 3 more names. In this other case, we are not going to insert nulls. So we say whose name are we using? Someone can okay. Let's just have a name now.
Anthony.
Anthony for the first name.
Yes.
So we have Anthony, comma. Last name is going to be
Pascal.
Pascal. Oscar or Pascal?
Yeah. Pascal.
Okay, so for the other name, we have what?
Friday.
Or
Friday. Okay, so let's use the Emeka. And the email is going to be Anthony Pascal at, maybe let's use Yahoo now, yahoo.com. Then because let's remove this created as in this case, so it will just generate this name for us. I don't want to be typing much. So with this now, we can also have another value. So which other name again are we using?
Let's use Della Sharon.
You say?
Della Sharon.
Which is the first?
D-E-L-A-D-E,
okay.
Yeah, then Sharon.
Okay, Sharon. That's this now. I believe this is correct.
Sharon.
Okay, maybe we can just have it as this. So that, sorry.
It's
Yeah.
S-H-A-R-O-N. Sharon. Simple.
S-H-A.
O, yes, R-O-N.
Okay,
Yeah,
so we can have this, and the other name should be specified because we'll specify the calling name there. We can just say, we can say Tunde again.
Yeah.
So for this, we have Della. Okay. At gmail.com. So with this now, we can have, I think I have an error. So once you have that squiggly line, there's an error. Like we forgot our comma here. It's also giving us an error. Running this again will give us, we insert those into our table. So let's try again to see what we have already. So we see we have this range of values in our table where we have the first three as null and these other ones are valid. So let's create another table. I think I created another table because I wanted this to be an extension of the other class. There are so many things we couldn't finish on the other class. So there's another, maybe users make order. So let's just create another table that is going to be this, because I would like us to also learn how to insert when we have a related table. So now we have 5 users.
Are you not done? Thank you so much.
Are we done? So let's just quickly do this so that if we are. So we can just say create, let me have this create a related table. So this is where we are going to enforce that our foreign key we've been talking about. So we can just say create table again. I want this to be others. Then inside others, we want to have other ID, right? And other ID should be integer. We also want it to be identity ID key. It should also move from 1 to 1. It should just be taking a step size 1. I want this to be the primary key. So what next? We enter our user ID. So this is actually where we are going to officiate that relationship. So we are going to have this as integer. And if you're going to define this key to be, you remember almost all the constraints we had in the other distance. So we are going to make it an integer. And also possibly we can allow it to be null depending on what our requirement. But in this case, let's say it's not null. So we just make it the same data type with what it's referencing. So we can say integer, or remember int alone also makes this. So to make it a foreign key, we simply say foreign key. Foreign key. Now references, we just call the table it is referring to user. References users, then user ID. So what we are saying here is, let me other data and this is. So what that is saying is simply that, I will expand and explain to us, or let me just finish. So what this is saying, okay, so what this is saying, we are saying user ID, this user ID should just be a foreign key because we already have a primary key to this table. So we are bringing a key foreign to it from another table into it. And we are just saying it's referencing so this references is a keyword. Once you say foreign key, you say references, then the name of the other table you want it to reference. In brackets, you pass in the column name you want it to reference. So in this case, we want this user ID to be exactly this, to reference this other user ID key. So that's why we said users and the user ID here. So I think we have other dates there. We can also make these other dates auto-generate. We have user other dates, which is date time. So we can make it default to auto-generate. And we have status. So I'll also explain something about the status. Let me go. So we have user other dates. So other dates is going to be a date time, right? Other date is going to be a date time. Then let's default it to, let's make it to whenever, exactly when the order was made, it should generate the time and filling that. We don't want to be filling order time by ourselves. So next is status. This status is going to simply be an envasher, but we want to restrict it to some range of values. So we want it to be envasher. It shouldn't be 50 since we let's just say I can just say 10. I don't think any distance is more than 10 here. So we can just say 10, or let me just say 12 so that I don't envasher 12. Not null. I will explain this, not null. Now this is another constraint. This is check. We use this kind of constraints to ensure we don't have some values that don't make sense. Let's say, for instance, if we are collecting order amounts, people order and want to collect the amount they have ordered, it doesn't make sense for us to have a negative number there, right? So if we also have a range of values where we just want our order status to be either pending, shipped, delivered or cancelled, we use this kind of this thing to enforce it. We just say check. I don't know. So this is just for, I'm going to move it to the next line so that we can see. And if I move it to the next line, I will indent it so that it's obvious to me or whoever is reading that this is a continuation of this line. So I'll just indent.
Finish now.
So I'll just indent. Someone said this thing is, Mike is, we just say this is in this range of values, pending, because we defined it as mVasha. We just specified some. So what this does is, if we try to fill in a value that is not within this range we are delivered, cancelled. So these are our range of values that make sense to us. But remember, there was an opening bracket here, so we are going to close it back. Let me. Okay, so we still have total amounts, but before that, we need we need the total amounts. So these total amounts, you know, people buy. It's going to be a decimal because people can buy something and it has some decimal. Why am I making it decimal? So let me just ask. 10, 2. Why am I making it decimal?
Yeah, because the prices of food.
Please, can you go over this status and this
Yeah, I'm
decimal
going
stuff,
to.
please?
Yeah, I'm definitely going to go over them. So now we understand up to this point. Okay, let me explain this user I. Whenever we declare, like we are just listing other constraints, we declare that it must be an integer, we declare the identity. That's the same way we do foreign key. So if we want a key to be foreign to a table and it's referencing another table, we simply also include in our list of stuff foreign key references, you name the name of the table and the column is referencing. That means this is taking value, like it's feeding from values from the other table. That's what this means. There is another way to declare foreign key constraint, but let's not use that until we are comfortable with this. So other dates is exactly like what we had then, where sign up created as. Then for status, this status, if we want to have a range of value, like we want to know the status of our order, has the order been delivered? Is it shipped? That means it's on transit, or is the order pending or cancelled? We want to track this. So, you know, we've declared it as characters, which means whoever is entering values can enter whatever he likes. But with this check, once we say check, it means be sure that this value starts with false within this range. We can say, like in this case now, for this total, let me also put a check there. I can say check. So check that. So once you say check, you open brackets and define your constant. You can continue on the same line. Let me continue on the same line before I now move down. Check that the total amount is greater than 0. That means we cannot have a value that is, we can't have a negative, someone can't buy and we are owing him. So what this is,
But
like
this
in
this
addition,
status now, you use a status in, but this total amount now, you're not using
yeah,
any command. So what's
yeah,
the
I'm using
difference?
this. I'm using this because this is easier, so that when you get the concept here, I'll now explain this other one. You get?
Okay,
Do you
okay.
understand? Do you understand this one that I'm doing now? This one now, we just say total amounts is going to be a decimal. It can run up to 10 digits, but the decimal places should just fall within 2 decimal places. We don't want to have more than 2 decimal places. We don't want it to be null. We don't want another that doesn't have this thing. So I want to check because we are also checking because we don't want. We can also say default here. So this check now ensures it's just checking if the value whoever is entering is less than 0, it will return an error. It will tell you that no, we can't have another amount that's less than 0. If we also want to have a default value, just in case someone doesn't enter a value, we don't want to have no. We simply say default. We simply say default and put 0 here. So that means if you don't enter other amounts, we should have 0. Okay, yeah, it's supposed to be here. Do you get all of these? Or I should still, let me remove this one if it's becoming much for us.
No, it's okay. I understand that total amount. It's only the status system.
Total amount.
Yeah.
If you understand total amount, therefore means you can understand status. It's the same arithmetic, basically.
Yeah, it's the same arithmetic, but in this case now we have a list of values. You know, if I remove this without this check, if I comment this out and comment this out, then create a table, what we have is just status enVasha. That means anyone on the status, I'm allowing people to put whatever they like. So just the way we fill the value for the other one,
Yeah,
anyone
yes,
can just
yes,
say
yes,
status
yes.
going, status Mike. So because we want to enforce that integrity, we don't want to see some values that will surprise us. Because whoever is going to analyze it might just be interested in, let's see how many this thing was shipped today. So the person is going to issue a query that will just filter out those ones that were. So that's why we are saying all the range of values should fall within either pending, shipped, delivered, or cancelled. Anything outside this is invalid.
Okay.
So for others, please, if you don't understand, always try and ask. There's no way I will know you don't understand. Ask. If I can't answer, we have other people, like a lot of us already know, and we have some people who know this. So if I can't answer, someone can come up. And me, I learn as we teach. So always ask your questions if you feel like you're lost anywhere.
Root status. Can't we just write the status, then we put the comma, we write our comments instead of put that in. So is that in that I just need to know if I want to relate such a command to other people, you need to be able to defend what you are.
Yeah. No, you can't do that. This in, we will do that when we, very soon, I think in our next class, we'll handle those. We'll talk about the in operator. We talk about operators. We have the in operator. We have the not in operator. Just think it of as a set or a collection. It's just confirming if whoever is entering exists within this list of values. So that's an in operator. We have something like that in sets. We can say if you draw a Venn diagram or collect some sets, you say this exists there. So when we say not in, we mean it is not in that list. We can also write one that will say, make sure it's not in this value. Anything that is outside this value is valid. So always use in. We'll
So
deal with
it means the in
more.
works for lists or one or more stuff.
So
Yeah,
the
when
in
we
means
have a
that
list.
the value should be in there,
Yeah,
be in the list.
yeah.
Okay.
So with this now, we can go ahead and create our table. Remember, this is another table we are creating. Executing this, if everything goes well, will give us another table. So let's check. If we refresh now and go back to our database, we should see it was an illustration. So we now have two tables. One is user, the other one is order. Let's still do so if we do this to check their relationship, just the way we used to do, last time we learned how to, from here, generate our empty relationship. So we can just do what we learned from one of our bosses and say this. Nope. I have to go into the database. So we'll move this way. I'm just trying to show you that we already have that relationship because for virtue of that, this thing we say the references. So if we do this, move down to this, and we have these two tables. So let's select them and add. If you add now, you see that there's a relationship between this table and this table. And if you look at them closely, let's expand. You will know that the one that has the primary key, has the, so look at this. if you look closely, this is the primary key, the user, the one we created before. We had the primary key and we took the primary key and made this a foreign key here. So this is the one side of the relationship and this is the many side of the relationship. So basically what we are just writing as code is exactly what we have been doing, clicking around. Do we have more questions here so that we insert values to this?
Excuse me, Mr. Michael, why is that relationship one to many?
You say?
Why is the relationship one to many?
Okay, we explained that in we said whenever you take a primary key from one table and make it a foreign key in the other table, if you don't enforce uniqueness, it's a one-to-many relation. I think we've explained this exhaustively in our first two classes. We took our time to hammer on relationships. So that's what it is.
Okay.
That's what it is. And what that means is, remember, we have orders and we have users. So a user can order as many times as he wants. You can order today with your account. You can order tomorrow. You can even order 2 today or 3. But an order have a unique user that ordered it. So it's a one-to-many relationship. You can just go over or read up. We have a PDF. We have a PDF I sent. You can read up on that. I think that PDF does a very nice job in explaining the relationships. So others understand why it's a one-to-many, right?
Yeah, for me, I understand why it's a one-to-many.
So for others, do we understand?
Absolutely.
Okay. So I think we'll move on and we insert into this table. Now, whenever I want to insert into this table, I think, did we enforce uniqueness? Okay. So we wouldn't like to, whenever we reference, like if we reference, if for us to say that whoever is making this order is number 1, we can just say, who is number 1? Once we do this, once in that order ID we put 1, that means we are saying it's Michael Oko that placed the order because it's an ID key. We are referencing to an ID key in another distance, which if we want to, so let's just do that. So in this case, we can insert, I have some values, but maybe we can copy from that or build our own. Let me take from that so that we can be a bit fast. So to insert into this, we would have made that, required. We would have made this required. So we can, if had it been we made this required, that's where we made it not null. But in this case, we didn't do that. If we made it not null, that means if you're trying to, and which is what it's supposed to be, it's supposed to not be null because there can't be an order without a user ordering it. So this is a design error. But we can just make do with that and pretend as if we know what we are doing. But adding to this database, we can actually add user ID 6, which doesn't exist yet. We don't have a user ID 6 because we did not make this not null. If we put user ID 6, it will take it. And that's wrong. But let's go on so that we don't waste time. So to insert values into our table, this came up and went. We simply do what we did before. So who can tell me? We just do insert into order. We list our values. Let me have this and hide this. So insert into orders. What are the? I can't really drink water. So we list columns from our order table, right? we are going to take tables. We are going to take columns from our other table. Are we going to, okay, is this correct? Are we supposed to do this? Are we supposed to do this? Remember this ID key, ID column, and it auto generates. So we want to allow it to fill it by itself because we wouldn't know. Maybe someone deleted a row and we might not always know where whoever stopped. So the best thing is for us to leave it since it fills by itself, and that's even the essence of using this ID key, and starts from user ID. So let's say the person that made this order is user. If I want to say the person that made this order is user Samson, how do I do that? Okay, we need user ID, other dates. No, we can leave other dates. Why are we leaving other dates? Sorry. Why can I leave other dates?
It's auto-generated.
Yeah, because we have defaulted it to a value. Why can I? Okay, so for this in status, I can just say user ID. Then for this, we'll just say we are leaving other dates. We want to put status. So we'll have status. We can also leave this total amounts, and this goes, right? Because I defaulted it to 0. With this now, that means if we don't put any value for it, what we'll have is 0, right? Are we following, or I should just remove this?
Yes.
Let me
Yes.
remove it. Should I leave it? Let me remove it so we
Leave
can
it
be
so that
adding
it
the value.
default to 0.
Okay. So I'm just trying to get your attention to how our database definition affects the way we write. So we can have status, but let's say someone's mic is hello? Someone's mic is noisy. Someone's mic is noisy. Okay. So let's have so we have user ID status, and I say we can leave this. Other dates can fill itself. User ID, we need it. This one generates by itself. So total amounts, we can just say total amounts. Then next we say what? Values. I like to shift this twice so that values it will stand out. So we have values. You can also use small letters. Values. You start giving the values you want. So now I want to insert. I want to make claim that who made this this particular transaction or who placed this order is user Samson. So how do I show that it's Samson that made this? Remember, this is our users table. How do I show that this transaction we are trying to initiate now was initiated by Samson? Does anyone have
use
idea?
of the primary key.
Yeah, we can make use of the primary key because we say this primary key references, this foreign key references the primary key in the other table. So in order to fit that, we are going to say 1. Saying 1 tells us that, okay, no, not 1. We are going to say 2, right?
2.
Yeah, we say 2. So saying 2 means we are referring to Samson, that Samson was the one. The essence of doing this is for us to see that table. So the status, we can just say this thing is delivered, right?
Yes.
If we give any other value outside what we've given, it will give us an error. So maybe we'll try the first one and the next one we give a wrong value. So here we can just say he ordered the whatever worth of 17, and we try to run this thing. So running this, we insert that value into our table. Let's try to do what we've been doing for the other table. We can just say select asterisk, select star. We'll explain all of this from from our orders, right?
Order.
So if we run this alone, it's going to show us some value. You see, if this a order 1, that's the first order initiated by user 2, and this user 2 is that person we had. The order date
Samsung.
was given to us as today, this moment we are doing this thing, and it is delivered. Total amount is this. So let's try to give to do the same thing and not give a valid this thing. Let's say we made a mistake here, deliver, and we try to run it. It's not giving us any error, but when we try to run this, because of that check constraint, it's going to, you see, it says the insert statement conflicts with a check constraint. You understand? We did not name the constraint, but maybe as we go on, we learn how to name our constraints. So the conflict, because we have decided that we don't want to have any value that is not from that list. What is doing this is that our in operator. So this is wrong, except if we have delivered here. So if we have maybe D here and we decide this is 2 and this person's value was just 1, 2, or let's just say this person just didn't order much. Running this now that we've corrected this, doing this should insert into that table. So let's try. This is also delivered. So I don't know if we are seeing how our integrity definitions is affecting the way we insert into our tables. So if we run this again, we now have the user 3 also delivered. So we can say, now because this is a one-to-many relationship, we can see how for user 3, we can say user 3 has a distance that is shipping. I don't know if that was the shipping or I used capital shipping. It's also case sensitive. Was it? Let me check. Okay, small. It's also case sensitive. So we can say that user 3 also ordered something worth 1, 2, and it's shipping now. So we run this. As long as we are staying within the, what's wrong? Okay. Share constraints. What's it saying? Share constraint. Are we not having shipment? Okay, shipped. I used shipped, sorry. You see? So once we give anything that is not valid, it's warn us. And it's good for the database and also good for whoever is coming to analyze, because the person just knows that the status of what our order could either be pending, shipped, delivered, or cancelled. So if you allow people to just throw in whatever they have into your database, it makes everything very chaotic. So a well-designed database allows whoever is analyzing whatever he's analyzing to do it without much stress. All those plenty data cleaning, you can handle it while you're designing your database. So when we run this now, I believe this should go. If we check this again, you see that the same user, that's user 3, has ordered twice because we said it's a one-to-many relationship. So one particular user can order many. We can have more and more and more and more. Maybe we can have user 5 ordered, then shipped. We can also decide to include more columns. Maybe we don't want this to be generating it for us. Okay, or let's test the other thing. We can say in this case, we don't want to have total amount because we already defaulted, but this doesn't make sense. So let's say, okay, maybe the way we define it, we want to say that nobody can order anything less than 500. So we can put that in that our constraint that for there to be an order, the value of that order must be up to 500. So we'll put it here, but we already defined we've created our table. So let's leave it as it is and just continue. So now we have status and we don't have this value. Running this, we still put something into our distance, but I believe it should put, what was that? Check. Check constraints, 5, other amounts, conflicts, database illustration, according to amounts. We said we defaulted it to something now. We had this before we created the database.
Yes.
It's not supposed to return this error now. Because in event of we not supplying a value, it's supposed to give that column 0. But it's saying some stuffs. Let me try again. So some of these places we are struggling with, all these mistakes we are making, you should go and find out why it's like that. Go and research, make your own work. You get? Just try and make your own work. I don't know if we are following what we are doing in this class. We can always ask questions. So let's
Wait,
take it
not be
back.
sleep, you dey sleep so. Eh?
Is it me? Okay, so
Okay, sir. We forgot to add total in the yes in this box where what you just did now. I think that's the
yeah,
problem.
I did that because I was thinking saying that this defaults to 0 means whenever we don't specify this, fill it for us. So I was
I
trying
think
to
maybe
test
that's
if this is working, but for some reasons I will figure that out. So let's try again. So these are the 5. Let's not use shift. Let's use the pending. His own is pending. His other is pending. And we include let's just say he bought for 1.5 or 1.4. So we try to add this. This goes. If we enforce that not null on our foreign key, let me try something. I want to add for a user that doesn't yet exist in the other table. Let's say user 7. And we add, we can just say cancel this order, right? And his order is 1, 8. Let me see if that relationship enforces it. Okay, yeah, this is working. So we don't necessarily need to specify. Did we get what we saw? We don't necessarily need to specify not null here. The foreign key itself enforces that once we have this kind of relationship, it enforces that whatever we are putting here, for there to be an order, there must be a user. I just tested it now. This user doesn't yet exist in our database. There's nothing like user 7 in our database. So I tried to add a value for user 7 who doesn't exist in the other table. And it's telling us that we have conflicted our integrity, whatever. So we can't add for a user that. So let's try for user 6. User 6 is still not going to work until probably we create a user that will be that 6. So it doesn't work. So let's go back to our where we're inserting into users and insert maybe Emmanuel. Emmanuel is now going to be Emmanuel Chidebere. They make stuff like that. So if we add this user now, let's just add one. I don't want to have to. So if we add this user now, this user is going to take ID number 6, right?
yes, ID number 6.
So it's going to take ID number 6. So it's done. If we try doing this, we did this the first time and it was not working because there is no user as user number 6. But if we now do this, it's going to work this time around. Why? Because we already have user number 6. So that foreign key integrity or whatever ensures that if we must have a transaction in this table, it must have been initiated by a user in the other table. If we start writing query, yeah, I will show you how to connect 2 tables together or how to ensure without even connecting them, we call them subqueries, how to do so many things that touches other tables. You confirm that this is like this in this table, then you do whatever you want to do in wherever you're doing. So I don't know. Let me ask so far. Do we have questions or confusion or things that we want to be clarified? Anyone can ask so that we talk about them.
But in inserting our values, do we need to put cancel and all those things in column again, in as much they have specified it in our syntax. I think it should just be like how we wrote a 1,800. Do we need to put it in column again?
Okay, now if you want to follow exactly the order that our table was defined and not skip any value, you don't necessarily need to start listing this. Like, let's do one that should look like that. If I just want to insert into this thing, I can just say insert into order. I don't know if this is what you are asking. Insert into order. We list what we want to do, but we must not skip any of the rows, any of the columns, and we must not reorder it. What we are doing, I can decide to bring, depending on how I define my, I'm coming, Control Z.
Sorry, I'm not talking about the order. I'm talking about the one you put in column. The
Which
cancelled.
line? Okay, here.
Yeah.
Okay,
No, it's the only one
what?
that's the signs in the column. Others doesn't. You don't need column. So, and
Okay,
I'm
you
very
mean
sure that the column does not appear in the table.
Is it a column or double quote? I mean single quote.
Sorry, the single quote rather, not column.
Okay.
Sorry.
Now look at from how we defined our database. We said this is enva-sha. That's characters. So how we represent characters or enva-sha or strange in SQL is by using single quotes. This other one, if you look at this, user ID, we defined it as an integer. So 6 is an integer. We define this as an amount, total amount. So you're following exactly what you did during your table definition. You understand? So if you want to put a value for, I think for this table, this is the only one we defined as a strange, as envasha. That's the word for it when you're dealing with databases. So this is the only one we defined as a envasha. We must respect that if we remove this and put anything else, it's going to give us an error because that was not how we defined it. It's just meant to help you protect you against users putting nonsense in your database because those nonsenses will give you a lot of time to make sense out of. So right from when you're defining designing your database, you make sure you stop all those things ahead of time. So this now you're already seeing squiggly brackets. So in order to handle whatever, anytime we are dealing with strange, envasha as database call it, we always put them in single quote, not double quotes. If you start programming with other languages, like Python allows you to use both double quote and single quotes to represent a strange. And the name for envasha in Python is strange and other languages. JavaScript also allows that. It allows you to use a double quote and single quote to refer to strange. But for here, it's strictly single quotes. Whenever you use double quotes, you're referring to column names or table names. When we start querying, I will still go in details about that. So it's because of who it is in our database definition. That's why we are using that single quote. Please, others, if you have questions, just ask so that I don't know if we should wrap up or we go into querying. I'll just introduce briefly how to query a database, how to drag this thing. Like now that we already have stuffs in this thing, I can just say stuff like this. Let me just say, select, I want to pull, select asterisk from others, where user ID, what's that? That was user ID, right? Where user ID is equal to select. I will show you how to do all of these. Select the first name. First name. This is first name. Select first name from Okay. So with this now, we can start exploring our database. Let me just not worry. I wanted to write this thing, but you asked me plenty questions. So we can go and confirm something from the other table and use it to make our job. We can just pull up, or let me just say select asterisk from others, where other names from others. Is it others or other? It's others now. Where, okay, this is wrong. Other names. Other names. This is not giving me intelligence. Is no. I'm not having voice. Others is the table. So why are you giving me this? Let me try. I'm coming. So I can just say, let's see other name. There should be other name for others now. Okay, there's no other names for others. Sorry, I was giving the wrong. So from it was our user table that we have stuff like that. Users. So where user other name is not. So I just want to know those people that didn't specify their username. So it will just give us the ones that are known. We can say it's not known. So we can say count. Let's count. We want to count how many persons that don't have their this thing. So very soon we'll start doing things like this. It's going to tell us how many persons whose first name is, let's say, no first. So we have 3 persons who did not specify their username. We can also say this as. So let's not go so deep as.
This one is I think
We'll start doing
do
this very soon.
next class. Yes.
Yeah, we'll do it next class. So let's ask our question so that we go in. Once we are done with this class, I think we are now equipped to write queries. Like we can now write queries without being scared that there are things we will touch that people will say, I don't know how come. Already we've understood our data types, relationships, how things connect to each other, and this. So let's ask our questions because we might not be coming back to this class again.
Bro, no problem.
Yeah.
I don't really have question, but can you give us a finished table? Let's just write the query that will present the table. Maybe
Okay. All right. When
we come to the class next class, then you give us the solution so that we know.
Okay. What will happen? What will happen? You don't have this. I had wanted to share my code with you, but just watch the video and try to do this. Don't use that click and drop. Do it this way, like the way we've done it today. Then try and feed some values into them. Try and feed some values into both order and this. Make sure the users is the primary key and this is the related key, the secondary key. So let me screenshot and send in the group. Or should I share the code we used? It doesn't even make sense because I'm not writing them in any specified order. So let me just do this. This is your assignment. But people are not asking questions. I don't know. The ladies didn't attend much today.
I believe if they watch the video, I think that will be a backup. So that is why.
All right. So from let me drop this on our group chat as your assignment. So we don't have questions, right? Let's close now.
Yes. Thank you, boss.
Yes, I think that's all for today. Thank you so much for everything, sir. We really appreciate your time and effort.
Yeah, I thank you guys for coming. If you don't, you're even helping me refresh. So thank you for coming. I think we are done for today since we are not seeing questions like we used to have before. So just
See you
before we
guys
go,
tomorrow. Okay.
so I think we should have a class on Wednesday, so that we can do 3 classes this week. I don't know if we'll be having other classes, but I feel Wednesday, then Saturday.
Okay, that's okay by us. Just update in the group so that everybody can know.
Because we still have a very long way to go. We just got used to the environment. We have a lot of things to do. Outside learning how to query a database, we now learn. I have to learn how to make sense, how to do the analysis itself. Being able to query a database is one good thing. Then to look out for what you should be looking like, all those your histogram, this. You can actually get your data well structured here before exporting them to Excel, where you now do your visualization. So thank you all for coming. I enjoyed today's class. That means you guys did the assignments. Thank you so much. So we'll
Thank you so much.
see. Yeah, if it's going to work on Wednesday, we'll do that. If it's not convenient, maybe we have other classes. We'll choose a convenient date for that. So thanks. Yeah, bye-bye.
Goodbye and good night. May God bless you and your efforts.
Amen. All right.